Hi, my name is Matt Rossbaum from the University of Montana, and I'll be sharing a short video with you today about how to use what is known as the L algorithm to find the least common multiple and the greatest common factor of two whole numbers. So let's go ahead and get started with the L algorithm. So we're going to do the L algorithm, and our sample problem will be find the least common multiple of 16 and 24 and the greatest common factor of 16 and 24. Okay, so the L algorithm comes to us from the Singapore Math Series. Seems to use this a lot. Seems to be taught quite a bit in America now, although I think it was first taught in Singapore, or at least championed by the Singapore Math Curriculum. So let's go ahead and start the algorithm. We'll first talk about how to do it, and then turn it around and talk about, well, why does it work? So we'll go ahead and show you how to conduct the L algorithm. So the L algorithm starts with the two numbers in question that you're trying to find the LCM or the GCF of. So I'll put 16 and 24 up. And then usually what happens is there's a line that's drawn down the middle between the two. And a table forms kind of conducted, I guess, here, line across the top, and then a line down the side. And then what happens in the L algorithm is we simply successively divide out common factors. It's probably most efficient to start with small factors so that we find them all. So what I usually do is teach my students to start with the smallest factor common to both that's not trivial. Of course, one it would divide into any of these, any two numbers, so we really, that doesn't really help us to divide a 1 out. But the next number above a 1 would be 2. So if I take a 2 out of both 16 and 24, divide a 2 out as a common factor, I get an 8 here and a 12 here. And I see that another 2 will come out, so I'll just continue successively dividing out by 2's until no more will come out. I get a 4 and I get a 6 here. And another 2 will come out, I get a 2 and I get a 3 here. And then what I would do is I would go on and check the next number up, a 3. Well, 3 goes into 3, but it doesn't evenly divide 2, so 3 won't work. And then I get to 4, and I think to myself, well, 4 is greater than 3 and 2, so it will not divide either, and neither will any other number greater than 4. And so I'm done at this point with the L algorithm. These are the numbers that will divide out of 16 and 24 both. And this is what's left when I take these numbers out of 16, and what's left when I take these factors out of 24. So the first thing you can do with the L algorithm is right away find the greatest common factor. Why don't I give you 10 seconds to think about where on the diagram you can find the greatest common factor of 16 and 24. If you have a partner with you, go ahead and verbalize this to your partner now. I'll give you 15 seconds to think about that. Okay, if you decided that the greatest common factor of 16 and 24 was found here on the L algorithm's diagram, then you are correct. It is 2 times 2 times 2, which is equal to 24. So the greatest common factor of 16 and 24 in the L algorithm can always be found in the left-hand column. The reason that that makes sense is because these are the numbers that can be that divide both 16 and 24. So they're factors of both. So they are common and they're factors. And the reason they're the greatest factors is because when I get to the end, I can take no others out. So in other words, I've taken everything out in terms of factors that I can, bit by bit, and then I just simply reconstruct them. Oh, I made a mistake. It's not 24, it's 8. I simply reconstruct them using multiplication to find the greatest common factor, which is 8. Okay, let's go ahead and move on and talk about what the least common multiple of 16 and 24 is. Okay, I'll give you 15 seconds to think to yourself, now where on the diagram could I find the least common multiple of 16 and 24? If you said that the least common multiple of 16 and 24 could be found by taking the greatest common factor and adding into it these extra pieces, then you were correct. It turns out that indeed the least common multiple of 16 and 24 is 2 times 2 times 2, these 3 pieces, times 2 times 3, these 2 extra pieces. And now you can see why this thing is called the L algorithm, because in the end what you're looking at is an L to find the LCM. So kind of a nice connection. The L algorithm gives you an L in the LCM. So it turns out that if we multiply those out, then what we get is 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 3 is 48. And indeed that is correct, that the LCM of 16 and 24 is 48. Now why would this make sense? Let's talk about why that works. The first thing you should notice is that the least common multiple is a multiple of 16 because the factors of 16 are these 3 and that one. The least common multiple is also a multiple of 24 because the factors of 24 are these common factors plus the extra 3. So we definitely have the fact that they are multiples. We also know that they're a common multiple because since I put the 2 and the 3 in, I know that I've got contained in there a 24 and a 16. So this number has to be a multiple of both 16 and 24. If you want to think about that, you can see that these pieces here make it a multiple of 16. And if I use the underline above, these pieces here would make it a multiple of 24. So it's definitely a common multiple. Now, why is it the least common multiple? And this is the reason why. The reason why is in order for it to be a multiple of 16, it has to have 4 2's. In order for it to be a multiple of 24, it has to have 3 2's and a 3. In order for it to be the least multiple, it has to have the least amount of factors, prime factors, in order to make it a multiple of both. Turns out that in order to make it the least multiple, you just need an extra factor of, say, 3 in the 16 to make it a multiple of 24. So that's the reason why it's the least multiple. Well, I look forward to you mastering the L algorithm and teaching it to others in our summer academy.